Close your eyes for a moment and let yourself float into the infinite expanse of the universe. Picture a canvas so vast, so unimaginably large, that it stretches beyond the edges of human comprehension. Stars twinkle like distant memories, galaxies swirl in silent dances, and somewhere, hidden in this cosmic tapestry, lies a mystery so profound it defies explanation. Tonight, we'll journey together into the heart of this enigma, a place known as the Great Cold Spot. It's a region of space so cold, so eerily different from its surroundings, that it feels like a whisper from the early universe itself. As we drift through the stars, let your mind wander, let your thoughts dissolve into the quiet hum of the cosmos. This is not just a story about space, it's an invitation to explore the unknown, to rest your mind, and to dream of the secrets that lie waiting in the cold, dark corners of the universe. So, take a deep breath, relax, and let the stars guide you into a peaceful slumber. Where are you joining us from tonight, and what time is it there? Let us know in the comments as we begin this celestial journey together. Now, as we drift deeper into the cosmos, let's turn our attention to the Great Cold Spot itself. Imagine a patch of the universe so cold, so strikingly different from the warmth of the stars and galaxies around it, that it feels almost like a cosmic anomaly. This is the Great Cold Spot, a mysterious region in space where temperatures drop far below what we'd expect, creating a chilling contrast to the rest of the universe. It's as if the fabric of space itself bears a faint, lingering mark, like a bruise left behind by some ancient, unseen force. Astronomers first discovered this enigmatic feature while studying the cosmic microwave background, or CMB, which is essentially the afterglow of the Big Bang. The CMB is like a snapshot of the universe when it was just 380,000 years old, a time when the first light began to travel freely through space. Within this faint glow, the Great Cold Spot stands out as a cold patch, a place where the temperature is just a fraction lower than its surroundings. It's not just a small dip, it's a vast, sprawling region stretching across billions of light years, making it one of the largest structures ever observed in the universe. To picture it, think of the Great Cold Spot as a cosmic bruise, a faint but unmistakable imprint on the canvas of the universe. It's a reminder that even in the vastness of space, there are still mysteries waiting to be uncovered, secrets hidden in the cold, dark corners of existence. And as we explore this strange and fascinating feature, we'll begin to unravel the questions it raises about the nature of the universe itself. What could have caused such a vast and cold region to form? Is it a remnant of the early universe, or something even more extraordinary? The answers, like the Great Cold Spot, remain shrouded in mystery, waiting for us to uncover them. Now, as we shift our gaze to the very foundations of the universe, let's explore the cosmic microwave background, or CMB, in greater detail. This faint glow, often referred to as the afterglow of the Big Bang, is one of the most important tools astronomers have for understanding the early universe. It's like a time capsule, capturing the state of the cosmos when it was just 380,000 years old, a time when the universe had cooled enough for light to travel freely for the first time. Before this moment, the universe was a dense, hot soup of particles, too chaotic for light to escape. But as it expanded and cooled, light broke free, leaving behind this ancient imprint that we can still detect today. The CMB is more than just a relic of the past. It's a treasure trove of information. By studying its subtle variations in temperature and density, scientists can piece together the story of how the universe evolved. These tiny fluctuations, some warmer, some cooler, are the seeds from which galaxies, stars, and even the great cold spot eventually grew. Think of it like a cosmic fingerprint, unique to our universe, revealing the conditions that shaped everything we see around us. But what makes the CMB so special is its ability to highlight anomalies like the Great Cold Spot. These irregularities, though small, are like whispers from the early universe, hinting at processes and events that occurred long before galaxies formed. The Great Cold Spot, for instance, stands out as one of the most puzzling of these anomalies. Its unusually low temperature challenges our understanding of how the universe evolved, raising questions about whether it's a remnant of the Big Bang itself or the result of something even more mysterious. In essence, the CMB is a window into the universe's infancy, offering clues about its birth and growth. It's through this ancient light that we can begin to unravel the secrets of the Great Cold Spot and other cosmic mysteries. And as we continue to study this faint glow, we're reminded that the universe is full of surprises, waiting for us to uncover them. Now, as we venture deeper into the cosmic mystery, let's uncover the story of how the Great Cold Spot was first discovered. It was the Planck satellite, a marvel of modern astronomy, that brought this enigmatic region to light. Launched in 2009 by the European Space Agency, Planck was designed to map the cosmic microwave background with unprecedented precision. Its instruments, finely tuned to detect the faintest whispers of ancient light, scanned the skies for years, collecting data that would reveal the universe's earliest secrets. Among the countless temperature fluctuations recorded by Planck, one anomaly stood out: a vast, unusually cold patch in the southern hemisphere of the sky. This region, later dubbed the Great Cold Spot, was colder than its surroundings by a tiny but significant margin. At first, scientists were puzzled. Could this be an error in the data? Or was it something far more profound? As they scrutinized the findings, the evidence became undeniable. The Great Cold Spot was real, and it was unlike anything they had seen before. The discovery sent ripples through the scientific community. Astronomers and cosmologists alike were captivated by the implications. What could cause such a massive cold spot in the fabric of the universe? Some speculated it might be a supervoid, a vast region of space with fewer galaxies and less matter than average. Others wondered if it could be a remnant of the early universe, a cosmic scar left behind by some long-forgotten event. The questions multiplied, each one more intriguing than the last. The Planck satellite's findings didn't just reveal the Great Cold Spot, they opened a door to new possibilities. For the first time, scientists had concrete evidence of an anomaly that challenged their understanding of the universe's structure and evolution. The discovery sparked debates, inspired new theories, and set the stage for further exploration. It was a reminder that even in the vastness of space, there are still mysteries waiting to be uncovered, and that every discovery brings us closer to understanding the true nature of the cosmos. Now, as we shift our gaze to the sheer magnitude of this cosmic anomaly, let's take a moment to truly grasp the scale of the Great Cold Spot. Imagine, if you will, a region so vast that it dwarfs even the largest structures we know in the universe. The Great Cold Spot spans an astonishing 1.8 billion light-years across, a distance so immense that it's almost impossible to comprehend. To put it into perspective, our Milky Way galaxy, with its hundreds of billions of stars, is just a tiny speck in comparison, stretching a mere 100,000 light-years from end to end. The Great Cold Spot isn't just big, it's a cosmic giant, a sprawling expanse of coldness that defies imagination. Think of it as a cosmic ocean, stretching far beyond the horizon, its depths filled not with water, but with a chilling void. If galaxies were islands in this ocean, the Great Cold Spot would be a vast, empty sea, where the islands are few and far between. It's a region where the usual bustling activity of the universe seems to slow down, as if time itself has taken a breath. This immense scale isn't just a curiosity, it's a clue. The size of the Great Cold Spot suggests that whatever caused it must have been an event of unimaginable power, something that left its mark on the very fabric of the cosmos. To further illustrate its enormity, consider this. If you could travel at the speed of light, it would take you 1.8 billion years to cross the Great Cold Spot from one side to the other. That's longer than the time it took for complex life to evolve on Earth. It's a reminder of just how small we are in the grand scheme of the universe, and yet how much there is still to discover. The Great Cold Spot isn't just a cold patch in the sky. It's a window into the mysteries of the universe, a reminder that even in the vastness of space, there are still wonders waiting to be explored. As we continue to unravel the secrets of this cosmic enigma, let's turn our attention to the theories that attempt to explain its existence. Could it be a supervoid, a region of space with fewer galaxies and less matter? Or is it something even more extraordinary? The answers may lie in the very structure of the universe itself. Now, as we delve deeper into the mystery, let's consider one of the most compelling theories about the Great Cold Spot. Could it be a cosmic void, a supervoid, to be precise? A vast region of space where galaxies and matter are sparse, almost as if the universe has carved out a hollow in its fabric. Supervoids are not uncommon in the cosmos. They are like the empty spaces between the threads of a cosmic tapestry. But the Great Cold Spot is no ordinary void. Its sheer size and the extreme coldness it exhibits make it a standout anomaly, even among these already peculiar structures. To understand how a supervoid could create such a cold spot, we need to look at how voids interact with the cosmic microwave background, or CMB. The CMB is the afterglow of the Big Bang, a faint whisper of light that fills the universe. When light from the CMB passes through a supervoid, it loses a tiny amount of energy as it climbs out of the void's gravitational well. This energy loss causes the light to appear slightly cooler, creating what scientists call the integrated Sachs-Wolf effect. In theory, this could explain why the Great Cold Spot appears colder than its surroundings. But here's the catch. While supervoids can cause temperature dips in the CMB, the Great Cold Spot's temperature drop is far more dramatic than what typical voids produce. The scale and intensity of this coldness suggests that if the great cold spot is a supervoid, it would have to be an exceptionally large and empty one, far beyond anything we've observed before. This raises questions. Could such a massive void exist? And if so, how did it form? The answers are far from clear, and this uncertainty keeps the mystery alive. Adding to the intrigue, recent observations have revealed that the distribution of galaxies in the region of the Great Cold Spot doesn't perfectly align with the supervoid theory. While there are fewer galaxies in the area, the deficit isn't significant enough to fully account for the extreme coldness. This discrepancy has led scientists to wonder if the Great Cold Spot might be something even more unusual, a cosmic void combined with another, yet unknown, phenomenon. Or perhaps it's not a void at all. As we ponder these possibilities, one thing becomes clear. The Great Cold Spot challenges our understanding of the universe's large-scale structure. It forces us to question whether supervoids alone can explain such anomalies, or if we need to look beyond our current theories. Could there be other forces at play, hidden mechanisms in the cosmos that we have yet to uncover? The search for answers continues, and with each discovery, we inch closer to unraveling the secrets of this enigmatic cold spot. With this in mind, let's turn our attention to the strengths and weaknesses of the supervoid theory, examining the evidence that supports it and the questions that remain unanswered. Now turning to the strengths and weaknesses of the supervoid theory, let's examine what makes this explanation both compelling and contentious. On one hand, the idea of a supervoid aligns well with our understanding of how the universe's large-scale structure works. Supervoids are known to influence the cosmic microwave background, or CMB, through the integrated Sachs-Wolf effect, which causes light passing through these regions to lose energy and appear cooler. This mechanism provides a plausible explanation for why the Great Cold Spot might exist. Observations of other supervoids in the universe have shown similar, though less dramatic, temperature dips in the CMB, lending credibility to the theory. However, the Great Cold Spot presents a unique challenge. While the supervoid theory offers a logical framework, the scale of the temperature drop observed in this region is far greater than what typical voids produce. For the Great Cold Spot to be explained by a supervoid alone, it would need to be an extraordinarily large and empty one, something unlike anything we've ever detected. This raises questions about whether such a massive void could naturally form. Given our current understanding of cosmic evolution, the sheer size required to account for the coldness pushes the boundaries of what we know about the universe's structure. Adding to the complexity, recent studies of galaxy distributions in the area of the Great Cold Spot have revealed inconsistencies with the supervoid hypothesis. While there is a noticeable lack of galaxies in the region, the deficit isn't significant enough to fully explain the extreme coldness observed. This mismatch suggests that if a supervoid is involved, it might not be the sole factor at play. Perhaps there's an additional phenomenon amplifying the cooling effect, or maybe the Great Cold Spot is the result of multiple overlapping voids. Alternatively, it could hint at something entirely different, a cosmic anomaly that defies our current models. The supervoid theory also faces challenges when it comes to explaining the great cold spot's precise location and shape. If it were a simple void, we would expect a more uniform distribution of coldness, but the great cold spot's boundaries are irregular and its temperature variations are uneven. This irregularity complicates the picture, suggesting that the void, if it exists, might be interacting with other structures or forces in ways we don't yet understand. Despite these challenges, the supervoid hypothesis remains one of the most studied explanations for the great cold spot. It provides a tangible starting point for further investigation, offering a framework that scientists can test and refine. Yet, as we've seen, the evidence is far from conclusive. The great cold spot continues to defy easy categorization, reminding us that the universe is full of surprises. As we explore alternative theories in the next section, we'll see how this cosmic mystery might be even more complex and fascinating than we initially thought. As we venture beyond the supervoid theory, the great cold spot invites us to consider even more extraordinary possibilities. Could this cosmic anomaly be the result of something far more exotic than a simple void? One intriguing idea is the concept of cosmic textures, hypothetical structures that may have formed in the early universe. Imagine the universe as a vast, intricate tapestry, woven together in the moments after the Big Bang. Cosmic textures would be like tiny knots or imperfections in that fabric, regions where the fabric of space-time itself is twisted or folded. These textures, if they exist, could create temperature anomalies like the great cold spot, leaving behind a faint but detectable signature in the cosmic microwave background. Another fascinating possibility is that the great cold spot could be the imprint of a parallel universe. This idea stems from the multiverse theory, which suggests that our universe is just one of many, each with its own unique properties. If another universe collided with ours in the distant past, the impact could have left a mark on the cosmic microwave background, creating a region of unusual coldness. While this theory is highly speculative, it captures the imagination, offering a glimpse into the boundless possibilities of the cosmos. Yet another explanation involves defects in the early universe, such as cosmic strings or domain walls. These defects would be remnants of the universe's rapid expansion shortly after the Big Bang, regions where the fundamental forces of nature behave differently. If such a defect passed through the area we now call the Great Cold Spot, it could have disrupted the distribution of matter and energy, leaving behind a cold patch in the CMB. These defects, though theoretical, provide a compelling way to explain the Great Cold Spot's unique characteristics. Each of these theories, cosmic textures, parallel universes, and early universe defects, offers a different lens through which to view the Great Cold Spot. While none have been proven, they highlight the creativity and curiosity of scientists as they grapple with this cosmic mystery. The Great Cold Spot, with its enigmatic coldness, challenges us to think beyond the familiar, pushing the boundaries of our understanding and inviting us to explore the universe's most profound secrets. As we continue our journey, we'll delve deeper into these ideas, uncovering the science and speculation that make the Great Cold Spot one of the universe's most captivating puzzles. Now turning to the concept of cosmic textures, we find ourselves exploring one of the most intriguing possibilities for the great cold spot's origin. Cosmic textures are hypothetical structures thought to have formed in the early universe, during a time when the fabric of space-time was still cooling and settling after the Big Bang. Picture the universe as a vast, intricate quilt, still being stitched together in its infancy. Cosmic textures would be like tiny ripples or folds in that quilt, regions where the fabric of space-time is slightly twisted or knotted. These imperfections, though incredibly small in scale, could have profound effects on the universe's structure. If cosmic textures exist, they could explain temperature anomalies like the Great Cold Spot. As these textures evolved, they might have created regions where the distribution of matter and energy was uneven, leaving behind cold patches in the cosmic microwave background. Imagine dropping a pebble into a still pond. The ripples spread outward, creating patterns on the surface. In a similar way, cosmic textures could have sent ripples through the early universe, leaving behind faint but detectable imprints in the CMB. However, cosmic textures remain purely speculative. While they offer a compelling explanation for anomalies like the Great Cold Spot, scientists have yet to find direct evidence of their existence. Detecting such subtle features in the vast expanse of the universe is no small task. It requires incredibly precise measurements and a deep understanding of the universe's earliest moments. Despite the challenges, the idea of cosmic textures continues to captivate researchers, offering a tantalizing glimpse into the universe's formative years. As we consider this possibility, it's worth reflecting on the creativity and ingenuity of scientists who explore such exotic ideas. Cosmic textures remind us that the universe is full of mysteries waiting to be uncovered, and that even the smallest ripples in space-time could hold the key to understanding its grandest secrets. With this in mind, we move forward to explore another fascinating theory, one that takes us beyond the boundaries of our own universe. Now shifting our gaze to an even more mind-bending possibility, let's consider the idea that the Great Cold Spot might be evidence of a collision with another universe. This theory takes us into the realm of the multiverse, a concept that suggests our universe is just one of many, each with its own unique properties and laws of physics. Imagine a vast cosmic ocean, with each universe like a bubble floating on its surface. Occasionally, these bubbles might brush against one another, creating ripples that echo through the fabric of space and time. If such a collision occurred, it could leave behind a distinct mark in the cosmic microwave background, much like a fingerprint. The Great Cold Spot, with its unusual temperature drop, might be one such imprint, a cosmic scar from a long-ago encounter with another universe. This idea is both thrilling and speculative, as it pushes the boundaries of what we know about the cosmos. It challenges us to think beyond the confines of our own universe and consider the possibility of an even grander cosmic landscape. The multiverse theory itself is rooted in the concept of cosmic inflation, the rapid expansion of the universe moments after the Big Bang. During this period, different regions of space could have expanded at varying rates, potentially giving rise to separate universes with different physical properties. If these universes exist, they might occasionally interact, leaving behind observable traces like the Great Cold Spot. While this theory is still in its infancy, it offers a fascinating explanation for one of the universe's most puzzling anomalies. As we ponder this idea, it's worth noting that the multiverse remains a highly debated topic in cosmology. Some scientists embrace it as a natural extension of our understanding of the universe, while others remain skeptical, citing the lack of direct evidence. Yet, the Great Cold Spot serves as a tantalizing clue, inviting us to explore the possibility that our universe is not alone. It reminds us that the cosmos is full of surprises, and that even the coldest, darkest corners of space might hold the keys to unlocking its deepest mysteries. With this thought in mind, we turn our attention to another intriguing connection: the potential link between the Great Cold Spot and the enigmatic force known as dark energy. Now shifting our focus to another cosmic enigma, let's explore the intriguing possibility that the Great Cold Spot might be linked to dark energy, the mysterious force accelerating the expansion of the universe. Dark energy, which makes up about 68% of the universe, remains one of the greatest puzzles in modern cosmology. Its presence is inferred from the way galaxies are moving apart at an ever-increasing rate, but its true nature is still unknown. Could the Great Cold Spot hold clues to understanding this elusive force? One way to approach this question is by examining how anomalies in the cosmic microwave background, like the Great Cold Spot, might reflect the influence of dark energy. The cosmic microwave background is like a snapshot of the early universe, capturing the faint afterglow of the Big Bang. Any irregularities in this ancient light could provide insights into the forces that shape the universe, including dark energy. The Great Cold Spot, with its unusually cold temperature, might be a window into how dark energy interacts with the large-scale structure of the cosmos. Some scientists speculate that dark energy could have caused subtle distortions in the fabric of space-time, leaving behind imprints like the Great Cold Spot. If this is true, studying the Great Cold Spot could help us understand how dark energy operates on vast scales. For instance, if dark energy's influence varies across different regions of the universe, it might explain why certain areas, like the Great Cold Spot, appear colder than their surroundings. This idea is still in its early stages, but it opens up exciting possibilities for connecting cosmic anomalies to the broader mysteries of the universe. Another angle to consider is how dark energy might interact with cosmic voids, those vast, empty regions of space where matter is sparse. If the Great Cold Spot is indeed a supervoid, as some theories suggest, its connection to dark energy becomes even more intriguing. Dark energy's repulsive force could be more pronounced in these voids, causing them to expand faster and potentially creating temperature anomalies in the cosmic microwave background. This interplay between dark energy and cosmic voids could offer a new way to study the properties of both. As we delve deeper into this connection, it's important to remember that dark energy remains a largely uncharted territory. The Great Cold Spot, with its unique characteristics, provides a rare opportunity to explore how this mysterious force might leave its mark on the universe. While the evidence is still circumstantial, the possibility that the Great Cold Spot could shed light on dark energy's properties is a tantalizing prospect for cosmologists. With this in mind, we now turn our attention to the role of cosmic inflation in shaping the early universe and how it might have contributed to the formation of anomalies like the Great Cold Spot. Now shifting our gaze to the very beginnings of the universe, let's explore the fascinating concept of cosmic inflation, a theory that describes a brief but explosive period of expansion just moments after the Big Bang. Imagine the universe in its earliest moments, smaller than a single atom, suddenly stretching out faster than the speed of light. This rapid expansion, lasting just a fraction of a second, is thought to have smoothed out the universe, creating the remarkably uniform cosmic microwave background we observe today. But it also left behind tiny ripples, like fingerprints, that would later grow into the vast structures we see, such as galaxies, clusters, and even anomalies like the Great Cold Spot. Cosmic inflation is more than just a theory. It's a cornerstone of modern cosmology. It explains why the universe looks so similar in all directions, and why the cosmic microwave background is so uniform, with only slight variations in temperature. These variations, or anisotropies, are the seeds from which all cosmic structures grew. The Great Cold Spot, with its unusually cold temperature, could be one of these primordial imprints, a relic from the inflationary era. If inflation stretched out tiny quantum fluctuations into larger scale irregularities, it's possible that the Great Cold Spot is a magnified version of one of these early fluctuations. But how exactly could inflation have created something like the Great Cold Spot? During inflation, the universe expanded so rapidly that even the tiniest irregularities were stretched across vast distances. These irregularities eventually became the building blocks for the large-scale structure of the universe. Some regions ended up with slightly more matter, while others had less. Over billions of years, these differences grew, leading to the formation of galaxies, clusters, and voids. The Great Cold Spot, if it is indeed a supervoid, might be the result of one of these underdense regions left over from inflation. What makes inflation such a compelling explanation is its ability to account for both the uniformity of the universe and the existence of anomalies like the Great Cold Spot. Without inflation, it's difficult to explain why the universe looks the way it does. Yet, while inflation provides a powerful framework, it also raises new questions. For instance, what triggered this rapid expansion, and why did it stop? These mysteries keep scientists searching for answers, using tools like the cosmic microwave background to test and refine the theory. As we consider the role of inflation in shaping the universe, it's worth reflecting on how this brief but transformative period set the stage for everything we see today. The Great Cold Spot, with its enigmatic presence, serves as a reminder of the intricate processes that shape the cosmos. It's a testament to the power of inflation, a theory that continues to guide our understanding of the universe's origins and evolution. With this in mind, we now turn to the temperature anomaly of the Great Cold Spot itself, exploring how its unique characteristics challenge our understanding of the universe's early moments. Now, let's focus on the temperature anomaly that makes the Great Cold Spot so extraordinary. Imagine standing in a vast desert where the heat is relentless, but suddenly you stumble upon a patch of icy ground. That's what the Great Cold Spot is like in the cosmic microwave background, a chilly region standing out against the otherwise uniform warmth of the universe. This spot is about 70 microkelvin and colder than its surroundings, a difference that might seem small but is significant on a cosmic scale. To put it into perspective, if the cosmic microwave background were a calm ocean, the Great Cold Spot would be a sudden, unexpected cold current flowing through it. This temperature difference isn't just a curiosity, it's a clue. The cosmic microwave background is like a snapshot of the universe when it was just 380,000 years old, and its temperature variations tell us about the conditions of the early cosmos. The Great Cold Spot's anomaly suggests that something unusual happened in that region long ago. It could be the result of a supervoid, a vast region of space with fewer galaxies and less matter, which would cause light passing through it to lose energy, creating a colder patch. Or it might be something even more exotic, like a cosmic texture, a ripple in the fabric of space-time left over from the universe's infancy. Think of it like this: if the universe were a loaf of bread, the cosmic microwave background would be the crust, and the Great Cold Spot would be a small, oddly shaped bubble trapped inside. This bubble could have formed during the rapid expansion of cosmic inflation, when tiny quantum fluctuations were stretched into larger irregularities. Over billions of years, these irregularities grew into the structures we see today, including the Great Cold Spot. Its temperature anomaly is a reminder of how the universe's earliest moments continue to shape its present form. What makes this anomaly so intriguing is that it challenges our understanding of the universe's large-scale structure. If the Great Cold Spot is indeed a supervoid, it would be one of the largest ever observed, stretching over 1 billion light-years. Yet, even this explanation doesn't fully account for the temperature difference, leaving scientists to wonder if there's more to the story. Could it be evidence of a collision with another universe, or perhaps a sign of new physics waiting to be discovered? As we ponder these questions, the Great Cold Spot stands as a cosmic puzzle, inviting us to explore the mysteries of the universe's origins. Its temperature anomaly is not just a scientific curiosity, it's a window into the past, offering clues about the forces that shape the cosmos. And as we continue to study it, we may uncover answers that reshape our understanding of the universe itself. With this in mind, let's now explore the challenges astronomers face in mapping this enigmatic region and the techniques they use to uncover its secrets. Now, as we turn our gaze to the tools and techniques that allow us to explore the Great Cold Spot, we find ourselves facing a unique set of challenges. Mapping this cosmic anomaly is no simple task. The Great Cold Spot is incredibly faint, lying billions of light years away, and its subtle temperature differences are buried within the vast sea of the cosmic microwave background. To detect such a faint signal, astronomers rely on some of the most advanced technology ever created. One of the key instruments in this quest is the Planck satellite, a marvel of modern science designed to map the cosmic microwave background with unprecedented precision. Launched in 2009, Planck spent years scanning the sky, capturing the faintest whispers of radiation left over from the Big Bang. Its detectors were so sensitive that they could measure temperature differences as small as 1/1,000,000 of a degree. This level of precision is essential for identifying anomalies like the Great Cold Spot, which would otherwise be lost in the noise. But even with such advanced technology, the process is far from straightforward. The cosmic microwave background is not a static image. It's a dynamic tapestry of signals from across the universe. To isolate the Great Cold Spot, astronomers must carefully filter out interference from other sources, such as the glow of our own Milky Way galaxy or the distortions caused by intervening matter. This requires sophisticated algorithms and painstaking analysis as scientists sift through mountains of data to uncover the faint signature of the anomaly. Another challenge lies in the sheer scale of the Great Cold Spot. Stretching over 1 billion light years, it's one of the largest structures ever observed. Mapping something so vast requires a combination of wide-field observations and high-resolution data. Telescopes like the Atacama Cosmology Telescope in Chile and the South Pole Telescope have played crucial roles in this effort, providing detailed measurements that help astronomers piece together the structure of the Great Cold Spot. Yet, even with these tools, the Great Cold Spot remains elusive. Its faintness and distance make it difficult to study in detail, and its origins are still shrouded in mystery. To overcome these challenges, astronomers are constantly pushing the boundaries of technology. Future missions, like the next generation of cosmic microwave background observatories, promise even greater sensitivity and resolution, potentially unlocking new insights into this cosmic enigma. As we continue to refine our techniques and develop new tools, the Great Cold Spot serves as a reminder of how much we still have to learn about the universe. Each observation, each piece of data, brings us one step closer to understanding this mysterious region and the forces that shaped it. And as we map its contours and unravel its secrets, we are not just exploring a cold patch in the cosmos. We are uncovering the story of the universe itself. With these challenges in mind, let's now consider how the Great Cold Spot fits into the larger structure of the universe and what it tells us about the cosmos on the grandest scales. Now, as we zoom out to see the Great Cold Spot within the grand tapestry of the universe, we begin to understand its place in the larger cosmic structure. The universe is not a random scattering of stars and galaxies. It is a vast, intricate web of matter and energy, woven together by gravity over billions of years. This web is made up of galaxy clusters, long filaments of gas and dark matter, and enormous voids, regions of space that are almost entirely empty. The Great Cold Spot, with its staggering size and unusual temperature, stands out as a peculiar feature in this cosmic landscape. Galaxy clusters, some of the largest structures in the universe, are like bustling cities in the cosmic web. They contain thousands of galaxies bound together by gravity, surrounded by vast halos of hot gas and dark matter. Filaments, on the other hand, are the threads that connect these clusters, forming a network that stretches across the universe. And then there are the voids, immense, dark regions where matter is sparse, and galaxies are few and far between. These voids can span hundreds of millions of light years, creating a stark contrast to the dense clusters and filaments. The Great Cold Spot, stretching over 1 billion light years, appears to sit within one of these voids. but its existence challenges our understanding of how such structures form and evolve. According to our current models of cosmic evolution, voids should not produce such extreme temperature anomalies. The cosmic microwave background, which gives us a snapshot of the early universe, should be relatively uniform in these regions. Yet, the great cold spot defies this expectation, presenting a temperature drop that is far more significant than what our models predict. This discrepancy raises important questions about the forces that shaped the universe. Could the great cold spot be evidence of a rare, massive void that formed under unique conditions? Or does it hint at something even more profound, perhaps a flaw in our understanding of gravity, dark energy, or the very fabric of space-time? Some scientists have even suggested that the great cold spot might be the imprint of a collision with another universe, a tantalizing idea that pushes the boundaries of our knowledge. As we study the great cold spot in the context of the universe's large-scale structure, we are reminded of how much we still have to learn. It challenges us to refine our models, to question our assumptions, and to explore new possibilities. Each observation of this enigmatic region brings us closer to understanding not just the great cold spot, but the universe as a whole. And as we continue to map the cosmos, we uncover not only its secrets, but also the story of our own place within it. With this broader perspective in mind, let's now consider whether the great cold spot could simply be a statistical fluke, a random fluctuation in the cosmic microwave background, or if it holds deeper significance for our understanding of the universe. Now, as we turn our attention to the possibility that the great cold spot might simply be a random fluctuation in the cosmic microwave background, we enter a realm where chance and probability take center stage. The cosmic microwave background, or CMB, is often described as a near-perfect snapshot of the early universe, a faint glow left over from the Big Bang. It is remarkably uniform, with tiny variations in temperature that reflect the seeds of all the structures we see today: galaxies, clusters, and filaments. But could the great cold spot be nothing more than a rare, random blip in this otherwise smooth cosmic canvas? To answer this, we must first understand the nature of these fluctuations. The CMB is not perfectly uniform. It has small ripples, like the surface of a pond disturbed by a gentle breeze. These ripples are the result of quantum fluctuations in the early universe, stretched to cosmic scales by the rapid expansion of inflation. Most of these fluctuations are small and follow predictable patterns. However, the great cold spot is an outlier, a temperature drop so significant that it stands out even among the natural variations of the CMB. Scientists have calculated the statistical likelihood of such an anomaly occurring by chance. The results are striking. The probability of a fluctuation as extreme as the great cold spot appearing randomly is less than 1 in 100. To put it another way, if you were to simulate the CMB thousands of times, you would rarely, if ever, see a cold spot of this magnitude. This low probability has led many researchers to question whether randomness alone can explain its existence. Skepticism about the great cold spot being a mere statistical fluke stems from more than just the numbers. The spot's size and temperature anomaly are so extreme that they challenge our understanding of the CMB's behavior. If it were a random fluctuation, it would imply that our models of the early universe are missing something fundamental. Perhaps there are processes at play that we have yet to uncover, or maybe our assumptions about the uniformity of the CMB need revisiting. Adding to the intrigue, the Great Cold Spot is not just a cold patch in the CMB. It aligns with a region of the universe that appears to have fewer galaxies than expected. This correlation between the cold spot and a potential cosmic void further complicates the idea that it is a random fluctuation. If the spot were purely a statistical anomaly, it would be unlikely to coincide with such a large-scale feature in the distribution of matter. Despite these challenges, some scientists argue that the Great Cold Spot could still be a rare but natural occurrence. After all, the universe is vast, and even the most improbable events can happen given enough time and space. They point out that while the probability is low, it is not zero. In a cosmos as expansive as ours, the unexpected can and does occur. Yet, the prevailing view among researchers is that the Great Cold Spot is more than just a cosmic coincidence. Its existence pushes us to refine our models, to explore new ideas, and to question what we think we know about the universe. Whether it is a statistical fluke or a sign of something deeper, the Great Cold Spot remains one of the most compelling mysteries in modern cosmology. And as we continue to study it, we are reminded that the universe is full of surprises, waiting to be uncovered. With this in mind, let's now consider how the Great Cold Spot fits into the broader picture of the universe's structure and what it might reveal about the forces that shape our cosmos. As we step into the next chapter of this cosmic mystery, let's explore how the Great Cold Spot has left its mark on the field of cosmology. This enigmatic feature has not only puzzled scientists, but also reshaped the way we think about the universe's origins and evolution. Its existence challenges some of the most fundamental assumptions in cosmology, pushing researchers to refine their models and consider new possibilities. One of the most significant impacts of the Great Cold Spot is its role in testing the limits of our understanding of the cosmic microwave background. The CMB is often referred to as the baby picture of the universe, capturing the faint afterglow of the Big Bang. It provides a wealth of information about the early universe, from its temperature to its density fluctuations. However, the Great Cold Spot, with its extreme temperature anomaly, suggests that there may be aspects of the early universe that our current models cannot fully explain. This has led cosmologists to revisit theories about inflation, the rapid expansion of the universe that occurred just moments after the Big Bang. Could the Great Cold Spot be a relic of an unusual inflationary event, or does it point to something even more profound? The Great Cold Spot has also sparked debates about the large-scale structure of the universe. Its alignment with a region of space that appears to have fewer galaxies than expected has raised questions about the distribution of matter in the cosmos. If the spot is indeed linked to a cosmic void, it could provide clues about how such voids form and evolve. This, in turn, could shed light on the role of dark energy, the mysterious force driving the accelerated expansion of the universe. By studying the Great Cold Spot, scientists hope to uncover new insights into the interplay between dark energy, dark matter, and the visible structures we observe. Moreover, the Great Cold Spot has encouraged cosmologists to explore alternative theories that go beyond the standard model of cosmology. Some researchers have proposed that the spot could be evidence of exotic phenomena, such as cosmic textures, or even the imprint of a parallel universe. While these ideas remain speculative, they highlight the importance of anomalies like the Great Cold Spot in driving scientific inquiry. They remind us that the universe is far more complex and mysterious than we often assume, and that there is still much to learn about its origins and evolution. In addition to its scientific implications, the Great Cold Spot has also influenced the way we approach cosmological research. Its discovery has underscored the importance of precision in observing the CMB and the need for advanced technology to detect subtle anomalies. Future missions, such as next-generation CMB observatories, are being designed with the goal of uncovering more details about the Great Cold Spot and other cosmic mysteries. These efforts could lead to breakthroughs that transform our understanding of the universe. Ultimately, the Great Cold Spot serves as a powerful reminder of the dynamic and ever-evolving nature of cosmology. It challenges us to question our assumptions, refine our theories, and remain open to new possibilities. As we continue to study this cosmic enigma, we are not only unraveling the secrets of the universe, but also deepening our appreciation for its boundless complexity and wonder. And with each new discovery, we take one step closer to understanding the grand tapestry of existence. As we prepare to delve into the next phase of our exploration, let's turn our attention to the future of space observation and the tools that may help us unlock the secrets of the Great Cold Spot and beyond. As we look toward the horizon of cosmic exploration, the future holds immense promise for unraveling the mysteries of the Great Cold Spot. The next generation of space observatories and cutting-edge technology are poised to bring us closer than ever to understanding this enigmatic feature. Among these, the James Webb Space Telescope stands out as a game-changer. With its unprecedented sensitivity and ability to observe in infrared wavelengths, it could provide new perspectives on the Great Cold Spot, potentially revealing hidden details about its structure and origins. Imagine peering deeper into the cosmic microwave background, uncovering subtle patterns that have remained invisible until now. This could be the key to unlocking the secrets of the early universe and the forces that shaped it. But the James Webb Space Telescope is just the beginning. Next-generation cosmic microwave background observatories, such as the Simons Observatory and the CMB Stage 4 project, are being designed with even greater precision. These instruments aim to map the CMB with extraordinary detail, capturing temperature fluctuations on scales smaller than ever before. By doing so, they could shed light on whether the Great Cold Spot is a unique anomaly or part of a larger pattern in the universe's structure. These missions represent a leap forward in our ability to probe the cosmos, offering the potential to confirm or challenge existing theories about the universe's origins. One of the most exciting possibilities is that these future observations could reveal entirely new phenomena. For instance, if the Great Cold Spot is linked to a cosmic void, advanced telescopes might help us understand how such voids form and evolve over time. This could provide critical insights into the role of dark energy and dark matter in shaping the universe. Alternatively, if the spot is evidence of something more exotic, like a cosmic texture or a collision with another universe, these missions could offer the first concrete evidence of such phenomena. The implications would be profound, reshaping our understanding of physics and cosmology. Beyond these ambitious projects, international collaborations are also playing a crucial role in advancing our knowledge. Teams of scientists from around the world are pooling their expertise and resources to tackle the great cold spot's mysteries. By combining data from multiple observatories and employing sophisticated analysis techniques, they hope to piece together a clearer picture of this cosmic puzzle. This collaborative approach not only accelerates progress, but also ensures that diverse perspectives contribute to the search for answers. As we stand on the brink of these groundbreaking discoveries, it's worth reflecting on how far we've come and how much further we have to go. The Great Cold Spot reminds us that the universe is full of surprises, and each new observation brings us closer to understanding its deepest secrets. With every mission, every telescope, and every discovery, we are writing a new chapter in the story of the cosmos. And as we continue to explore, we are reminded of the boundless curiosity and ingenuity that drive humanity's quest for knowledge. With the tools of tomorrow in hand, the next phase of our journey into the unknown is just beginning. What we uncover about the Great Cold Spot could not only solve one of the universe's greatest mysteries, but also inspire new questions and possibilities. The cosmos awaits, and the answers are closer than ever. Now turning to the realm of imagination and creativity, the Great Cold Spot has not only fascinated scientists, but also inspired storytellers, artists, and dreamers. This enigmatic feature of the cosmos has found its way into the world of popular culture, becoming a symbol of the universe's endless mysteries. In science fiction, the Great Cold Spot has been depicted as a gateway to other dimensions, a remnant of an ancient cosmic event, or even a sign of extraterrestrial intelligence. Its chilling presence in the cosmic microwave background has sparked countless narratives, where it often serves as a backdrop for tales of exploration, discovery, and the unknown. Filmmakers and writers have used the Great Cold Spot as a metaphor for the vastness and unpredictability of the universe. In some stories, it becomes a destination for intrepid space travelers, a place where the laws of physics seem to bend, and reality itself becomes uncertain. These creative interpretations highlight the spot's ability to evoke a sense of wonder and curiosity, much like it does in the scientific community. By weaving the Great Cold Spot into their works, artists remind us that the universe is not just a subject of study, but also a source of inspiration. Visual artists, too, have been drawn to the Great Cold Spot's haunting beauty. Through paintings, digital art, and installations, they capture its eerie, otherworldly essence, often blending scientific accuracy with imaginative flair. These works invite viewers to contemplate the mysteries of the cosmos, encouraging them to see the universe not just as a collection of data points, but as a canvas of endless possibilities. The Great Cold Spot, in this context, becomes a bridge between science and art, a reminder that the pursuit of knowledge and the expression of creativity are deeply intertwined. Even in music and literature, the great cold spot has left its mark. Poets and composers have used it as a muse, crafting pieces that reflect its enigmatic nature and the emotions it stirs. Whether through haunting melodies or evocative verses, they capture the sense of awe and humility that comes from confronting the unknown. The great cold spot, in these artistic expressions, becomes a symbol of humanity's quest to understand the cosmos and our place within it. As we explore the great cold spot's presence in popular culture, we see how it transcends its scientific origins to become a cultural icon. It represents the allure of the unknown, the thrill of discovery, and the boundless creativity of the human spirit. Through the lens of art and storytelling, the great cold spot invites us to dream, to question, and to imagine the infinite possibilities that lie beyond the stars. And as we continue to uncover its secrets, it reminds us that the universe is not just a place of cold, hard facts, but also a source of endless inspiration. As we venture into the realm of possibility, the great cold spot invites us to ponder one of humanity's most profound questions. Could this mysterious region of the universe hold clues to the existence of life beyond Earth? While the great cold spot itself is a frigid expanse, its extreme conditions spark curiosity about the resilience and adaptability of life in the cosmos. After all, life on Earth has proven to thrive in some of the most unexpected and hostile environments, from the scorching depths of hydrothermal vents to the frozen tundras of Antarctica. Could the great cold spot, with its unique properties, be home to forms of life we have yet to imagine? Scientists have long speculated that life, if it exists elsewhere in the universe, might not resemble anything we know. In the great cold spot, where temperatures plummet far below the cosmic average, any potential life forms would need to adapt to conditions that seem inhospitable by our standards. Perhaps in this cold expanse, life could exist in ways that challenge our understanding of biology, organisms that metabolize energy differently, or even life forms that exist in states we cannot yet comprehend. The great cold spot, with its enigmatic nature, becomes a canvas for imagining the possibilities of life in the most extreme corners of the universe. Moreover, the great cold spot's potential connection to cosmic voids, regions of space with fewer galaxies and less matter, adds another layer to this speculation. If life were to exist in such a sparse environment, it might rely on entirely different mechanisms for survival, perhaps drawing energy from sources we have yet to discover. This idea opens the door to a broader discussion about the diversity of life in the universe and the conditions under which it might arise. Could the great cold spot be a testing ground for theories about life in the most unlikely places, while the search for extraterrestrial life often focuses on planets within the habitable zone of stars? The great cold spot reminds us that life might not be confined to such conventional settings. It challenges us to expand our thinking and consider that life could flourish in environments we once deemed impossible. This perspective not only enriches our search for life beyond Earth, but also deepens our appreciation for the resilience and adaptability of life itself. As we continue to explore the mysteries of the great cold spot, we are reminded that the universe is full of surprises. Whether or not this cosmic anomaly holds the key to extraterrestrial life, it serves as a powerful reminder of the boundless possibilities that await us in the cosmos. And as we gaze into the cold, dark expanse of the great cold spot, we are left to wonder, what other secrets might it hold, and what might they reveal about the nature of life itself? As we step into the realm of cosmic mysteries, the great cold spot stands as one of the universe's most perplexing enigmas. This vast, frigid region defies our current understanding of physics and cosmology, presenting a puzzle that has yet to be solved. Its existence challenges the very foundations of what we know about the universe, pushing scientists to rethink long-held theories and explore new frontiers of knowledge. At its core, the great cold spot is a reminder that the universe is far more complex than we often assume. While the cosmic microwave background, the afterglow of the Big Bang, provides a snapshot of the early universe, anomalies like the great cold spot disrupt this otherwise uniform picture. Its presence suggests that there are forces or phenomena at work that we have yet to fully comprehend. Could it be the result of a cosmic event from the universe's infancy, or does it hint at entirely new physics waiting to be discovered? One of the most intriguing aspects of the great cold spot is how it resists easy explanation. While some theories, like the supervoid hypothesis, offer partial answers, none fully account for its extreme temperature differences. This gap in our understanding keeps scientists on their toes, driving them to develop new models and conduct deeper observations. The great cold spot is not just a curiosity, it's a catalyst for innovation in cosmology, pushing the boundaries of what we thought was possible. What makes this cosmic anomaly so captivating is its ability to spark both wonder and frustration. On one hand, it invites us to dream of new possibilities, from exotic cosmic textures to the tantalizing idea of parallel universes. On the other, it reminds us of the limits of human knowledge, humbling us with the realization that the universe still holds countless secrets. For scientists, the great cold spot is both a challenge and an inspiration, a call to keep exploring, questioning, and imagining. As we ponder the mysteries of the great cold spot, we are reminded that the universe is a place of endless discovery. It challenges us to look beyond the familiar, to embrace the unknown, and to remain curious in the face of the unexplained. And while we may not yet have all the answers, the journey of unraveling this cosmic puzzle is a testament to the enduring spirit of exploration that defines our quest to understand the cosmos. Now, as we venture deeper into the heart of this cosmic mystery, the great cold spot invites us to reflect on something profound, the limits of human knowledge. This enigmatic region of the universe serves as a humbling reminder of just how much we still have to learn. Despite centuries of scientific progress, the cosmos continues to surprise us, revealing phenomena that challenge our understanding and push the boundaries of what we thought was possible. The great cold spot is more than just a scientific puzzle. It's a philosophical mirror, reflecting our place in the grand tapestry of the universe. It reminds us that for all our advancements, we are still explorers in a vast, uncharted expanse. The questions it raises about the nature of space, the origins of the universe, and the forces that shape it are questions that have no easy answers. And perhaps that's the point. The universe doesn't owe us clarity. It invites us to keep searching, to keep wondering, and to remain curious in the face of the unknown. This cosmic anomaly also teaches us the value of humility. In a world where we often pride ourselves on our knowledge and achievements, the great cold spot is a gentle nudge, reminding us that there is still so much we don't understand. It's a call to embrace the unknown, not as a source of frustration, but as an opportunity for growth and discovery. After all, it's in the gaps of our understanding that the most exciting breakthroughs often occur. At the same time, the great cold spot sparks a sense of wonder that transcends science. It invites us to dream, to imagine, and to ponder the possibilities that lie beyond our current grasp. Could it be evidence of a parallel universe, a remnant of a cosmic event from the dawn of time, or something entirely new, waiting to be uncovered? These questions don't just belong to scientists. They belong to all of us, as we collectively gaze up at the stars and wonder what lies beyond. In the end, the great cold spot is a testament to the beauty of the unknown. It reminds us that the universe is not just a collection of facts and figures, but a living, breathing mystery, full of surprises and secrets waiting to be uncovered. And as we continue to explore, to question, and to dream, we are reminded that the journey of discovery is just as important as the answers we seek. The great cold spot doesn't just challenge our knowledge, it inspires us to keep reaching for the stars, both literally and figuratively, as we strive to understand the infinite wonders of the cosmos. Now, let us embark on a journey through time, where the great cold spot becomes our guide, leading us through the vast and intricate history of the universe. Picture this. It all began with the Big Bang, a moment of unimaginable energy and creation, where the universe burst into existence in a flash of light and heat. From that fiery beginning, the cosmos began to expand, cooling and stretching, giving birth to the first particles, the first atoms, and eventually, the first stars. As the universe grew older, it began to weave its story, forming galaxies, clusters, and vast cosmic webs. And somewhere in this grand tapestry, the great cold spot emerged, a quiet anomaly that has silently witnessed the unfolding of time. Imagine it as a cosmic traveler, drifting through eons, carrying with it the echoes of the universe's earliest moments. Through billions of years, the great cold spot has watched as stars ignited and faded, as galaxies collided and merged, and as the universe itself continued to stretch and evolve. It has seen the birth of planets, the rise of life, and the endless dance of matter and energy, and yet it remains a mystery, a relic of a time long past, holding secrets that we are only beginning to uncover. As we follow this journey, let the great cold spot remind us of the beauty of time itself. It is a reminder that the universe is not static, but ever-changing, a living story written in the language of light and space. And as we stand here, in this fleeting moment of cosmic history, we are part of that story too, connected to the stars, the galaxies, and the great cold spot itself. So let us pause and reflect on this journey, this incredible passage of time that has brought us to where we are today. The great cold spot is not just a mystery to be solved. It is a bridge to the past, a guide through the ages, and a reminder of the infinite wonders that still await us in the vast expanse of the universe. Now, as we look toward the horizon of human discovery, the great cold spot beckons us with the promise of new frontiers in space exploration. This mysterious region, a relic of the universe's earliest days, holds the potential to unlock secrets that could reshape our understanding of the cosmos. Imagine, for a moment, the possibilities that lie ahead if we could one day send missions to study this enigmatic cold patch up close. The Great Cold Spot could serve as a cosmic laboratory, offering scientists a unique window into the conditions of the early universe. By studying its properties, we might uncover clues about the forces that shape the cosmos, from the rapid expansion of inflation to the subtle ripples in space-time that gave rise to galaxies. Future missions equipped with advanced telescopes and sensors could map its structure in unprecedented detail, revealing whether it is a supervoid, a cosmic texture, or something even more extraordinary. But the journey to the Great Cold Spot is not just about answering scientific questions, it's about inspiring humanity to dream bigger. Imagine spacecraft venturing into this vast, cold expanse, carrying instruments designed to probe its mysteries. What if we discovered evidence of exotic physics, or even hints of a multiverse? Such findings could revolutionize our understanding of reality itself, pushing the boundaries of what we thought was possible. The Great Cold Spot also reminds us of the importance of collaboration in space exploration. Unlocking its secrets would require the combined efforts of astronomers, physicists, engineers, and dreamers from around the world. It's a reminder that the universe's greatest mysteries are not meant to be solved by one nation or one generation, but by humanity as a whole, working together in pursuit of knowledge. As we ponder the future, let the Great Cold Spot inspire us to keep reaching for the stars. It stands as a symbol of the unknown, a challenge to our curiosity, and a testament to the boundless potential of human ingenuity. Who knows what wonders await us in this cold, distant corner of the universe? The journey is just beginning, and the discoveries that lie ahead could change everything we know about the cosmos and ourselves. With the next phase of exploration on the horizon, the Great Cold Spot invites us to dream, to explore, and to uncover the secrets of the universe. What will we find when we finally reach this cosmic enigma? The answer, like the Great Cold Spot itself, remains shrouded in mystery, but the journey to find it promises to be nothing short of extraordinary. Now, as the vastness of the cosmos envelops us, let us take a moment to drift gently through the stars, allowing the mysteries of the universe to cradle our thoughts. Picture yourself floating weightlessly, carried by the currents of space, as the Great Cold Spot comes into view. This immense, enigmatic region stretches before you, a quiet expanse of coldness that seems to hum with the whispers of the early universe. Feel the stillness of this cosmic void, a place where time slows and the noise of the world fades away. The Great Cold Spot is not just a scientific curiosity, it is a sanctuary of calm, a reminder of the universe's infinite patience. As you glide closer, let its cool embrace soothe your mind, inviting you to release the weight of the day and surrender to the tranquility of the cosmos. Imagine the gentle rhythm of your journey, the soft pulse of distant stars guiding you forward. The Great Cold Spot is a silent companion, a vast and mysterious presence that invites you to explore without urgency, to wonder without pressure. Here, in this quiet corner of the universe, there is no rush, no need to solve its mysteries, only the opportunity to exist, to breathe, and to dream. Let the great cold spot's stillness seep into your thoughts, calming the restless edges of your mind. Feel the vastness of space around you, a reminder of how small and yet how connected we are to the cosmos. Each breath you take is a part of this grand tapestry, a thread woven into the fabric of the universe itself. As you continue to drift, let the great cold spot's quiet presence lull you into a state of peace. Its mysteries remain, but for now, they are not puzzles to solve, they are stories to rest within, a cosmic lullaby that sings of the universe's endless wonder. Close your eyes and let the stars carry you deeper into this serene journey, where the cold is not a void but a gentle embrace, and the universe whispers its secrets in the language of silence. And as you float, let the great cold spot remind you that even in the vastness of space, there is a place for stillness, for rest, and for dreams. Let its quiet presence guide you into a peaceful slumber, where the mysteries of the cosmos become the backdrop of your dreams, and the universe itself becomes your sanctuary. Now, as we linger in the quiet embrace of the great cold spot, let us pause to reflect on the beauty of the unknown. This vast, enigmatic region is more than just a scientific anomaly. It is a testament to the universe's boundless complexity and its endless capacity to surprise us. The great cold spot whispers a truth that resonates deep within, that the cosmos is not just a place of answers, but a realm of questions, of mysteries waiting to be uncovered. There is a certain magic in not knowing, in standing at the edge of understanding and gazing into the infinite. The great cold spot, with its cool stillness and quiet presence, reminds us that the universe is not meant to be fully unraveled. It is meant to inspire wonder, to spark curiosity, and to invite us to dream beyond the limits of what we think we know. Think of the great cold spot as a cosmic mirror, reflecting our own smallness and yet our profound connection to the vastness of space. It challenges us to embrace the unknown, not as something to fear, but as something to marvel at. In its quiet expanse, we find a reminder that the universe is not just a collection of stars and galaxies. It is a story, ever unfolding, ever mysterious, and ever beautiful. As you rest within this cosmic lullaby, let the great cold spot awaken in you a sense of awe. Let it remind you that the universe is not a puzzle to be solved, but a mystery to be cherished. Its secrets are not obstacles, they are invitations, calling us to explore, to question, and to wonder. So, as you drift through the stars, let the great cold spot be your guide to the beauty of the unknown. Let it teach you to find joy in the questions, to find peace in the mysteries, and to find wonder in the infinite. For in the end, it is not the answers that define us, but the curiosity that drives us to seek them. And as you close your eyes, let the great cold spot's quiet presence remind you that the universe is not just a place of cold voids and distant stars. It is a place of endless possibility, where every mystery is a doorway to something greater, and every question is a step toward understanding. Embrace the unknown, for it is here, in the spaces between the stars, that the true beauty of the cosmos lies. Now, as the stars above gently guide us deeper into the night, let your mind wander freely into the vast expanse of the great cold spot. Picture yourself floating through its cool, serene embrace, where the universe feels both infinite and intimate. Here, in this quiet corner of the cosmos, the mysteries of space unfold like a dream, inviting you to explore its secrets with a sense of wonder and tranquility. Imagine the great cold spot as a cosmic sanctuary, a place where the noise of the world fades away, leaving only the gentle hum of the universe. As you drift through its stillness, let your thoughts dissolve into the vastness, carried by the currents of space and time. Feel the coolness of its presence, not as a void, but as a canvas of endless possibilities, waiting for your imagination to paint its stories. In this moment, allow yourself to become an explorer of the unknown, a traveler through the stars. Picture the great cold spot as a gateway to the universe's deepest mysteries, where every question leads to another, and every answer reveals a new layer of wonder. Let your curiosity guide you as you uncover the secrets hidden within its quiet depths. As you close your eyes, let the great cold spot's soothing presence lull you into a state of peaceful rest. Feel its cool embrace wrap around you like a cosmic blanket, calming your mind and easing your thoughts. Let the rhythm of the universe's heartbeat carry you into a deep, restful slumber, where dreams of distant stars and endless galaxies await. Tonight, as you drift off to sleep, let the great cold spot remind you that the universe is not just a place of cold voids and distant lights. It is a realm of infinite beauty, where every mystery is an invitation to dream, to explore, and to wonder. So, let your imagination take flight, and may your dreams be as vast and boundless as the cosmos itself. As we bring our journey through the great cold spot to a close, let's take a moment to reflect on the wonders we've explored. This enigmatic region, with its chilling embrace and cosmic mysteries, stands as a testament to the universe's infinite complexity. It reminds us that even in the vastness of space, there are still questions waiting to be answered, secrets waiting to be uncovered. The great cold spot is more than just a cold patch in the cosmos. It's a symbol of the endless mysteries that surround us, inviting us to dream, to question, and to explore. From its discovery in the cosmic microwave background to the theories that attempt to explain its existence, the great cold spot challenges our understanding of the universe. Whether it's a supervoid, a cosmic texture, or even a mark left by another universe, it sparks our curiosity and pushes the boundaries of what we know. It's a reminder that the universe is full of surprises, and that every discovery leads to new questions, new possibilities, and new wonders. As you drift off to sleep tonight, let the great cold spot inspire you to keep dreaming. Let it remind you that the universe is a place of endless beauty and mystery, waiting for you to explore it, whether in your thoughts or in your dreams. The stars above are not just distant lights, they are beacons of curiosity, guiding us to uncover the secrets of the cosmos. So, as you close your eyes and let the night carry you away, remember this: the universe is vast, but it is also yours to explore. Keep dreaming, keep wondering, and keep reaching for the stars. And if you've enjoyed this journey through the mysteries of the great cold spot, don't forget to subscribe, like, and hit the notification bell for more cosmic adventures. Until next time, sweet dreams, and may your nights be filled with the wonders of the universe.